Okay. Yes, we can start. Good afternoon. So today we have a second seminar from Professor Müge Akin on liquefaction case study in Turkey. So please.
Okay, thank you for the second day and for your attention and attendance. Actually, I'm going to start with before the liquefaction case studies, what I have early performed or just recently performed some analysis regarding to my study. And then I will be continuing with the other part, like including case studies. And then I will be continuing with the ongoing projects. I would like to give some examples from them. So as you already discussed and then learned that liquefaction is a complex phenomenon and deals with and starting with a point of the Niigata earthquake, and there are some requirements for it. But before we start, sorry, there should be a change, but anyway, I'm going to firstly talk about the tectonic activity and the important things that really would like to emphasize for the activity for seismically, and then I will be continuing about the microzonation study for my study PhD area, and then I will be continuing with the liquefaction case studies, as I told you. So in general, when you have a look, the area, the Anatolian plate, we have a big amount of problems that we are having so far, because Arabian plate is actually coming towards the Anatolian plate, and then there would be kind of movements that occur, which is a really famous North Anatolian fault zone, and it is similar to San Andreas fault zone actually. And the other Eastern Anatolian fault zone and the other Dead Sea fault zone that also goes down to the Red Sea actually. So these are the biggest fault zones that we are having. Besides, because of the extensional regime, we have some Horst and Graben system in Aegean area. So this is another part of view that we need to consider. So we are in just between these activities and this capable of faults that we are having as an activity that works on the area. So for the North Anatolian fault zone, I don't know if you have heard, or of course we are always talking about Istanbul biggest earthquake will happen. Actually, we believe in that because of the surface ruptures and the events that occurred just sequentially depending on the years or depending on the surface rupture that we are having because of the North Anatolian fault movement. There are some recordings and even some traces that we are having so far for this actually active area. So at that stage, I have actually worked the area which is closer to that surface rupture, which is called Erba, and there was an earthquake occurred in 1942 with a magnitude of 7.3 or so. But the important thing is there is a seismic gap that I am going to show you in that region. That's why we prefer to study there. And besides, during my microzonation study, I have all the true work with the geotechnical data, and besides additional ones, afterwards we had some seismic hazard analysis, some site response analysis, and then we prepared some maps depending on amplification, liquefaction base, and additional maps that I'm going to share and then show some of it. So with these maps, okay, we have the data and the interpretation, and then we decided that actually I should work on the system for multiple criteria decision analysis. So within this sense, we are giving some importance to the different layers and then dividing into the zones. So that would be easier for us to get the final microzonation map. As I told you, this is the study area that I have already worked there, and there is a seismic gap, and then depending on the events and the occurrence interval, so it is necessary to focus on that area for us. In general view of the area, this is the updated version of geology. This is the alluvial units, and there are some pluyos and deposits that regarding as a formation, different formation. But in alluvial stage, you are having the surface rupture of the 1942 earthquake event, actually. And besides, there was a, I don't know if it is can clearly seen, old urban settlement there. And then after the earthquake, they have to move southern part of the area in 1950s or so. But now they are still doing some construction closer to the fault zone, right, at that stage. And here you can see the deposition layers in alluvium, which are really heterogeneous. And what I did, here you can see some of the applications of borehole activities, some seismic events, and some refraction microtremor and additional things with the kind of limited budget that I can obtain at that stage. And with the CPT applications, but we have some limitations because of the gravel effect in that region. So we couldn't go further down until 30 meter depth. So we have just used especially SPT boreholes while they are having a 30 meter depth, which would be necessary for us. We have prepared, I actually prepared the groundwater table, and the thing is that distance to surface rupture would be critical. We thought that, and we, based on the model, used some distance effect also with the surface rupture. During that stage, I have used several next generation attenuation models in order to have the distance surface rupture that occurs in that system. Besides, for the liquefaction part, as I have also given some of the examples, but in general, I have started with the possible liquefaction activity and then continue with the liquefaction potential index, liquefaction severity index map, and then the other settlement-based and the lateral spreading-based levels that we are having so far. And I have the amplification map. If you are willing to see, I can also share with this. I forgot to put it here. Afterwards, I actually did the results for two different approach, including different weighting systems. So I have considered different layers for microzonation, giving the different classes and different ranking systems. With the overlay analysis in GIS, I got two different maps, including liquefiable areas, or let's say unsuitable areas, detailed geotechnical investigation required areas, or some provisional or some suitable areas that also comprise with the real data for us. So this is the thing that I had done so far. So of course I have done other type of projects that maybe we can also discuss it later. So when we return to our case studies from Turkey, I would like to start with very recent earthquake that occurred in in the eastern part of Turkey. Not only the earthquake would be critical for us, also the liquefaction behavior occurred at that region was also critical. And by the way, I was living there, but at that day I wasn't there. So luckily I was out of city, so I didn't feel anything, or nothing happened. But afterwards we deal with many things to deal with all the way through. It was a magnitude with a 7.2, and within the different periods in October we had, and then afterwards we have another earthquake occurred in November. So we have felt twice the biggest actually fatalities. And here you can see some of the photos from the earthquake, or even some of the important and very, very structural failure that occurred. It is also interesting, there was a big hotel. It's totally collapsed after the second earthquake because of they cut the columns in order to have bigger areas. We learned that after in the city center, by the way, and some people were died, even Japanese, I think journalists also were there. So it's also interesting case for us, especially having that. In our campus area, again, we have some kind of damaged buildings, even destroyed buildings, especially closer to the lake area, because the campus is very closer to the lake, and we felt lots of problems that occurred in the region, even in some places very closer to the lake area. There are some lateral spreading and liquefaction behavior that we have also observed, but I don't have a chance to go and then study there because of the psychology of the earthquake and the other things. And then afterwards, they have built some temporary houses or some containers at that stage to stay all the staff, all the students there. It was really interesting period for all of us, actually. So when we return to the event of the earthquake, here you can see the map regarding to the behavior that occurs. It is also related to the North Anatolian fault zone that we can say. For the Karasu area, for the liquefaction part, here you can see this is the campus area that I showed you. And there is a river that passes like that. It's called Karasu River. All the way through the, depending on the activity of the fault zone, we have actually observed some lateral spreading and sand boiling effects occurred. Just after having the situation, some of our professors gone and arranged all borehole things, and then we have got just only 2 boreholes in order to observe the sand boiling behavior at that stage. And we have opened some try pits to get some sample for the site investigation of the liquefied area. It's a kind of flow type liquefaction we observed with the ground settlement. And there are some sand cones and sand boils we observed with the ejection of the liquefied soils onto the surface crack. And here you can see the river. And by the way, there are some landslide slope instability problems that occurred in the area. So these are the cracks spreading depending on the river and the distance that we are having. And as you can see, the activity depending on sand boiling. I have another photos for them. We have observed some points regarding to do that. And here you can see the river and the stage that we are having so far. But it is also interesting to that this photo, it's a kind of dike you can observe, and there are some traces of the liquefied soil, how you can easily observe the sand boiling effect that occurred at that stage. I wish we should have more, but unfortunately with the limited situation we had this. So here you can see, this is the river, this is the lateral spreading that occurred, this is the alluvial area, this is the first borehole that we are also working on that place. And there are some additional photos, I think it should be on the right side, with the coarse and fine-grained soil we have also observed in that region. And even with the lateral spreading and sand boil locations, you can see some of it. So how did we study? We took some samples and then had the sieve analysis results for the site classification, and we are trying to have potential of liquefaction and if they have totally have the situation, and then we compared them. And we have also taken some geophysical surveys with the prediction of SPT based VS data, and we have some measurements for VS data. We are trying to compare and then to understand the mechanism that the liquefaction related event actually. And here you can see the not real, let's say real earthquake recording, but it's far away from our side. That was the another gap that we are facing, because one of the station didn't work just during the earthquake, very closer one. So that was the really disadvantages we have. And here you can see regarding to the levels that we are having liquefied area, you can have some potential and severity index. They also confirm that we are having the liquefied zone that also that we are facing so far for Karasu liquefaction. So I will be maybe going too fast, but I need to continue with another example if you are ready, or if you don't have any questions until so far, or I think you have
a question on the first part of
Okay.
microzonation.
Okay, so
You should, I think it was the last slide you showed on this example.
you mean the microzonation part?
Microzonation, yes.
Okay. It would be easier to, I think, ask or discuss
Okay.
because, yeah.
So, this is a method in which you assign a ranking to all the side effects. So both amplification, both liquefaction, and you produce a kind of map, a final map,
Yeah.
in which you join all the aspects. Just to
So
understand this method.
actually, if you have a liquefaction induced ground deformation, that means if you have none, I'm giving very high level.
Okay.
That means that you are in the
Take into account all the side effects.
Yeah.
Liquefaction, amplification also. You divide the two interval for different amplification factor, right, I think.
Yeah,
Okay.
based on that. I have used, or depending on the data that I have, I should divide, for instance, into two.
The range of variation of amplification factor in
Exactly.
two intervals.
Yeah, that's
And
fine.
also you take into account also maybe distance to fault. So that meaning a kind of index of surface faulting, the displacement or something like this.
Yeah, I mean, from the structural point of view, when you
Okay.
are getting closer, that will be a disadvantages for you, for
Yeah, I
instance.
mean, a kind
Oh,
of
yeah.
yes, parameter to take into account the displacement imposed. Okay.
Mhm.
And you mix all these side effects in a unique parameter.
Not a unique, just overlay analysis. I made a formula regarding to that. When I am ranking that, which one would be preferable for your one layer? So would you like to stay very closer to the fault area or away for it? So when you have the less amount of point, that means that you are in the safe side. But you are having higher point, that means that I have also make some divisions regarding to the intervals that I am having for the maximum and minimum ones in between. And then I have prepared that map depending on that. So it is basically a geographic coordinated system that you are having, all of the way through that you are having the dangers or endangered zone.
So it's I mean, for the amplification, you make some side response analysis, of
Exactly.
course.
Mm-hmm.
And for liquefaction, is based also on simplified methods you apply or not?
No, I have taken into account all of the liquefaction possibility, liquefaction induced settlement, lateral spreading, all the things together with the combination of the liquefaction.
And how many data you need to prepare this to apply this method?
Yeah, actually too many, but when you have the, I mean, decision or the approach, it would be easier to understand and to assign some of the problematic areas that has the unsuitable areas like the zonation. So I think I should continue with the next event. So for Karasu liquefaction, as I told you, we have already had a publication for it. And for the another area, Düzce, after Kocaeli earthquake 1999, I have studied in that area. And just recently we have another earthquake that occurred with a 6-point magnitude, 6.0 magnitude in that region. I would like to also share the report. Just I have recently had it, but in Turkish. But anyway, I can give the example. So for the Düzce, it's very closer to area Kocaeli, or after 1990 August earthquake, we have another earthquake just similar to one earthquake. So just randomly or just maybe in 2 or 1 month period after that, we are having the second earthquake that occurs in the region. And so what exactly I did, I have studied Düzce because Düzce is very famous with the liquefaction at that stage, a very alluvial plain area. And I have tried to compare the preparation of the maps depending on liquefaction potential index and liquefaction severity index. And here you can see the place of Düzce, and this is the branch of North Anatolian fault zone that occurs in this area. And here you can see the biggest earthquakes that occurs in that region all through the after and before 1999 earthquakes. For this geology map, it is quite an alluvial material, and there are some settlement area. Also, we need to discuss the settlement degree depending on the liquefaction effects that occurs as a secondary in that region. With the preparation of these maps, unfortunately, it is hard to verify with the real data or real cases in somehow, but with the zonation of them, with the existing data, it really differs depending on if you are using liquefaction potential or liquefaction severity index, especially in terms of GIS-based system. And by the way, I have also considered different scenarios for the system. I forgot to tell you. This is, or for instance, liquefaction potential index for different scenarios, or even with the severity index. Why it differs like that? Depending on the magnitude of the earthquake and depending on the selection scenario or selection case that you're having as a PGA or the other that X on the regarding to the analysis you have. So I can give the other details for it if you wish regarding to that. But the other thing that I have to mention, it is really hard to find damage distribution for the area after an earthquake. If I have a chance to combine all of it, that would be easier for me to understand the liquefaction related events. Maybe it is necessary to be filled at that stage. And here you can see there are two different approaches depending on the damage distribution that occurs in the city center actually. So it's also interesting to observe this and then giving the rate of the system, because in here, as you can see, it says there are some distribution of highly destroyed within the colored area, but it is the somehow specific region of Düzce. So when we have the earthquake just recently, it's kind of away of the Düzce city center. It's called Gölyaka. It's somewhere here. So here you can see the intensity distribution for this range. It is also interesting because all over the people from the eastern part, even western part, felt the same earthquake. Because it's a very shallow depth earthquake, but we couldn't solve this. And according to the report, there are some actually site observations regarding to the some lateral spreading that occurred just recently. Went there, I don't know if they have measured it or took some sample or observed in the geotechnical way, because it is the report from Ministry and they are all related with the geology of the area or the tectonic event. But as far as I can see, there is a small lake, and depending on the lake, there are again some maybe lateral spreading related behavior occurred in that sense. But I have no option to have the geotechnical data and verify the other things for the system. So this is another issue that I have to mention. And here you can see the structural damage that occurred after 6-point Gölyaka Düzce earthquake. So it was too much, or we didn't expect it too much behavior depending on, especially from the structural point of view. So I have studied, maybe the studies will go on depending on the stage or the events that we are having after the earthquakes. So I would like to share another case study with the related another activity we did regarding to the, again, one earthquake, but this is the second one, and we have tried to evaluate, it's far away, this is one, and this is Erciş, is one of the suburban area of in the region, and we have got some data depending on SPT, CPT, and as well as some shear wave velocity based approach, and then we are trying to find out the liquefaction potential for that area, again with the different scenarios. So in here you can see within this sense, by the way, after the 2011 earthquakes, we have lots of liquefaction based or lateral spreading based cases occurred in a specific village, but we don't have any options again to have some geotechnical data from that. But there are some points here. You can see the distribution of the geology depending on, again, the lake and the behavior. And besides, we were trying to have the groundwater table of all over the city center through, in order to get some scaling and even, let's say, SPT based or VS based factors or different items. So why we are doing that? Because in this case, it's really for us to verify the real case, or even you don't have this, the authorities did not give you any opportunity to have you some microzonation or some work or some unsuitable areas that you are gonna also prove at that stage. So it's one of the maybe necessity that we need to have and give some options for them. So here you can see some of the actually methods that we had so far regarding to the different liquefaction severity and potential index. For severity index, we are using Sönmez et al. Or the Sönmez and Gökçeoğlu approach, probably different than that we have already discussed then earlier. And when we have a look deeper with this sense, with the LPI and LCI, here you can see, especially for the different magnitude or different Amax PGA value, and the distribution of the areas are totally different than each other, or different than the case that we are having. So why we are having that? This is actually SPT based, but you can have waste based. So it differs depending on, again, in this sense, with the comparison of the calculation or the selection of the methodology or so on. It goes something like that. So as a result, we thought that the use of VS-based liquefaction analysis, when you collaborate with the SPT test results, it should be quite advantageous for us, actually, comparing the specific site. But this SPT data may be misleading, or there are some, again, correction problems that we are having so far, and especially gravelly layers. So for us, we prefer to actually emphasize VS data, and VS approach would be critical for us in that sense. This would be another approach for liquefaction or liquefaction case history or story that I can say. So if you don't have any question, I will be moving on another case study or event that I need to share with you.
Parameter, which are the classes of risk?
It's also related or similar to potential index, actually. there are some, I think, level that also distributes the highly or extremely. I think there is a difference in between the layers or the zonation that you are having for the numbers. So I can share the method and the. It actually depends, like LPI. Yeah. Yeah, I mean, not it depends, just similar. Yeah,
Okay.
like that.
And your map, because I cannot read very well the region, in your map, so the results are similar between LPI and LSI, or there are potential difference even in the other map of CPT, SPT?
For instance, for here, it differs. Probably yeah. Sorry, you are right. This is threshold acceleration criteria. This is VS-based for the comparison. But for the LPI and LCI, yeah. You can see the color. Exactly. As for LSI, you can see a wider range of, for instance, when you compare the area for the same scenario, it differs. So you can be on the safe side. It says, for instance, high liquefaction, but in here, very high liquefaction or high liquefaction, it differs depending on the stage in between two. Depending on the height of the material that we are also calculating for the potential index, like, yeah, it requires other typical maybe formula or different formula than the potential index. But it really differs, especially if you have the case, for instance, with a magnitude with a higher or with a by the way, this is a 2011 earthquake result, for instance. This is 1970s, another important earthquake. Sorry about the things that I have tried to give all of the things at the same time. Maybe it cannot be readable too much, but this is 1976 Chaldron earthquake with a magnitude 7.1. It's similar to the one earthquake, actually.
Oh,
except
the difference between
yeah.
metals. Like the ILSI for the earthquake, there are some differences.
Yeah, because of the, yeah.
Which are the difference.
Okay, so maybe I can share the reference. It would be easier to follow the other parameters because some of them I couldn't remember as well. And just to be sure and mention that, thank you for the showing me. This is the threshold acceleration. This is the VS-based liquefaction factor of safety criteria. So I have to correct it in that sense. So for the another case, after 1990 earthquake, there are lots of studies were done with some researchers in that Izmit Bay region because it's a very huge amount of behavior, ground displacements, and some settlements, some liquefaction related things, since boiling or some serious damages were occurred in that region. That's because of the 1999 earthquake. And here you can see the distribution of Izmit Bay area. I think maybe I should make it bigger to stop our thing. If you wish, I can make it bigger as a figure because I agree with that. It's not clearly seen because there are some actually liquefied areas with the lateral spreading or vertical settlement. Like in here, the hotel is going towards into the sea. It was the really important case for us. Or even with this, I think with an explanation of the high level of liquefied or non-liquefable layer, you can have a chance or understand the principle that occurs all through the way area with the sense of lateral spreading and the behavior that occurs for different regions. regions. As you can see, there are many studies for different areas. This is the all combination and the explanation for liquefaction, actually intensity or severity in here, for instance. So the division, and these are the rock units, by the way, and these are the alluvial and fluvial deposits that you can observe all of through the failure mechanisms in the Izmit Bay region, actually. So these are the things for the liquefaction case stories that I can have and share. I would like to share just especially our studies with you. That's why I didn't consider the other additional ones. But if you are willing to learn, I can add additional case studies, or I can give. If you don't have any questions, I would like to give some information about some project that I am working on that. Maybe we can also discuss about that.
It's a question, the PS method used. I'm not an expert on that. Which methods you used?
Anderson-Stock approach generally we are using, yeah.
But there is also for like in the other methods, the correction for fine content or something like this.
I think there are some formulas for it, but including fine content correction or not, I couldn't be sure because it was a time. Yeah, it was a long time for me.
So anyway, the database are less constrained with respect to the CPT or SPT methods, maybe.
Yeah.
So,
but for our case, maybe if we have more data, we can have a comparison in between, within that range. But yeah.
But they have tested on inode test or surface wave test. It's not important. I mean, the technique you use for VS profile. No,
I have no idea actually about it. Maybe it differs depending on the application of the refraction microtremor, or even having some seismic records from the system. So for the ongoing project, nowadays we are having a microzonation project. We working and evolving in a kind of special soil in Kayseri, and I am having a project related with the determination of ideal house, which would be a kind of another discipline that we are also dealing with architecture. After an earthquake, I'm going to give some information about that. So for Izmir, we have an earthquake again, 2020. It's Samos earthquake, actually. It occurred depending on the fault system in that region, but it's really effective. Sorry, in that region, it is also effective in Izmir regarding to some special areas or some buildings that we have suffered a lot. That's why the municipality decided to have a consultant about the microzonation project, especially the model Bornova plane, in order to have the geotechnical data and the other amplification, even liquefaction, or the other microzonation activities that we are gonna have. And here you can see the distribution of the work that we are going to perform for the area. For each cell, we are going to have some CPT and SPT generally data we are going to obtain for the rock and for the soil material with a different depth. We'll be having them. Now the project has already been started with the drilling right now, and we'll be planning to have deep boreholes in order to reach the bedrock, to model the Bornova plane. And for the plane, there is another issue that also we need to consider: topographic effect in soil amplification. That's why we are trying to understand and model with a finite element approach with the program, if we can have, or if we can establish on that. And what else I should mention? Yeah, there are three different city center that we are going to consider divide into the in that sense, and we are considering landslides and rockfall, the other events in the seismic microzonation as well. That's seismic, let's say, microzonation, which can be called as it is. So this is one of the ongoing project right now that I am dealing with in Turkey. I'm going to no. This is totally different. This is microzonation project. For the second, yes, this one we are actually dealing with in Kayseri with this peaty soil. It's very. This is the Kayseri region. You can have or you can observe, especially this material in the industrial area. But as far as I can see, through the inside the city, we are having some similar problems regarding to this peaty soil. What we are exactly doing for the project, we are having some. These are the, by the way, tanks or the things that we are having, just pushing down and then taking to undisturbed samples from the organic material in order to test, actually, in order to apply some ground improvement techniques. So some of PhD students now working on them. One of them is working with a stone column inside the box of the taken sample from the site. And in the laboratory, they are having the column with geotextile or without geotextile. The other student also has, yeah, there should be another photo, but dealing with the jet grouting in the region. So we have all apparatus. He is working in the laboratory, preparing the columns with a single column or more than one column, having the load on top of it. And then prediction, or they are also calculating the settlement that occurs in that area. peaty soil is really problematic. You have 150 or so water content. Actually, it's kindly plastic, but it's somehow there are fibers inside. Because of the distribution of the fibers, if you have horizontal or vertical, it really differs the behavior of the soil. Anisotropy is totally complex in getting here. Even with the preparation of the stone columns or jet grouting, we are dealing with many problems because of the having exact or the proper column that we are having so far. So we are actually working on that issue. And maybe the last but not least, let's say, this is the last project that I need to mention. There are some approaches. I don't know if you have actually, Professor Amoroso mentioned that. Regarding to the some transition zones for the area or for the after an earthquake, you have solutions like emergency, some temporary or some core solutions for the housing. But what happens just suddenly and then big earthquake occurred in the region? What should we do, or what should we the authorities behave in that sense? So therefore, this is photos from actually one earthquake. They have actually sent the tents in the winter time, summer tents at that stage. They didn't consider the weathering condition, and then they have tried to build some cities temporary housing, and then they had the just permanent ones. So in Turkey, we have a problem. If you are in a village and if you are having the permanent house like that, that means that you cannot feed, for instance, your animal or etc. So in the past, we had suffered a lot. Therefore, while I was giving a course in architectural department, we decided that we should have this approach, and then at least we should have a chance to be involved in the system to be standardized for the all general. That's why now I am also involving in that project. So I don't know if it is not too much or not too boring, but I have tried to give a summary and then give some important things that I would like to share with you. So if you have any questions, I'll be very glad
Yes,
to answer.
I'm very interested in the peat soil because, of course, organic soil are problematic soils in terms of course, static problem in terms of settlements because they are very compressible soil layer, but they are also problematic in this seismic behavior.
Dynamic, exactly.
Because I study experimentally this behavior with my colleague from Rome. We collected some samples of Italian organic soils and we performed several cyclic tests. And our soils characterized by usually they are quite soft, of course, so they are prone to seismic amplification usually, and that they have also a very linear behavior and with a very small dissipation of energy. So they are quite problematic because in case of earthquake, they amplified a lot, of course, the seismic response because the classical, inorganic clays are generally characterized by very high damping at high strength, so they tend to de-amplify maybe in case of strong earthquakes. Organic soils are less dissipative, so they amplified a lot also in the high strain range during the strong earthquake. So it's a very peculiar behavior with respect to inorganic clays. So maybe it would be interesting to test. I don't know if you have some samples, these soils. The other problem is that, for example, the soils we tested were mainly with no fiber inside.
Okay.
So they were more or less isotropic behavior. This one, you told that they are characterized by some
Fibers.
fiber inside. So it's quite complex to study because you have to understand how to prepare the specimens and
Yeah, correct.
so it is important the direction of application of the loading with respect to the orientation of these fibers. So we never test this kind of organic soil.
I'm very glad to hear that. I was also looking for some possible, let's say, approach for the dynamic and even with the static conditions as well as we can discuss all Professor Amoroso. We have needed to have, let's say, some institute measurements and some laboratory works in order to get the dynamic properties of the soil, this type of peat. Actually, Professor Kramer had a paper for it. This was the maybe beginning stage when I am realizing that we are having the same turba or peat soil, but maybe nowadays we should look for some budget or financial in order to establish this type of, work. Yeah. But yeah, I'm totally agree, and then I'm very glad to hear.
Paper in which we study this organic behavior.
And I think there is a gap regarding to the behavior in the G over G max and the curves that we are using for the site response analysis for peat soil as well. There is a gap. I think we need to also discuss and then consider that issue as well.
They are very limited soil. We need the data and literature about organic soil. Those are also different and difficult to test.
Yeah. In Malaysia, there are lots of peat soil, as far as I can see. Actually, not only in Kayseri, we have in Sakarya, we have also, or in another regions, like similar sites that we are having as an organic soil, organic material. Thank you for your contribution. So any questions or anything you wonder? So from the, I don't know, online, there is no online? Okay.
There are people online.
Okay, I couldn't see that.
Okay.
So thank you for your attention and listening to me once more. Thank you so much. I'm very glad to be here and then with you to share the ideas and then discuss the important things, especially for me.
We have an Erasmus collaboration with Müge University and exchange of students into activities for long period or short period abroad or friendship or someone interested.
We would be happy all work together. I think it will really work. Thank you so much. Should I close this?
Okay, thank you, and we conclude the seminar. Bye bye.
Should I leave it back? Yes. Sorry, my voice is getting. I couldn't understand, but